Hello, everyone. My name is Brahim Elbuochikhi. I'm a product manager on MLKit. We, as a team, and many of us are actually right here, are very excited to tell you about MLKit. You've heard about it from Dave at the main keynote, and you probably even looked at our documentation. But in this session, we'll tell you a little bit more, some of the behind-the-scenes stuff that we've been working on. So let me get started. I think it's important to look back a couple of years and look at machine learning and what's been happening, the context. And I try to quantify this the best way I could, and one way is to look at Google Trends, the most reliable source of data. And in this case, you could see that over the past 8 years, we had a 50x increase in interest in deep learning, right? And deep learning is not a new technology. It's been around since the 70s. What's changed is that we can finally kind of deliver on the promise of deep learning. We have enough compute, memory, and power on some of these devices to actually run those models that have been developed for quite some time. And so I wanted to give you a very simplified, as a product manager, a very simplified view of machine learning, a 101. And in this case, you could see that essentially deep learning uses these layers and tries to mimic how the brain functions, right? And it tries to activate different neurons based on the specific kind of input it's getting so that it can ultimately arrive at that answer of whether this is a dog or a cat or a hot dog or not. And in this case, as you could see on that image, the output of that particular outcome is dog. And what we had before these sorts of algorithms was rule-based engines, where you'd have to actually configure the rules that will, if this and this and this and this and this, that's a dog, which does not scale. So because of that, deep learning has allowed us to get into so many more use cases and solve so many more problems that we had than we could before purely with rules engines. So that's cool. In particular, over the past 7 years or so, our ability and the machine's ability to perceive the world around it has gotten incredibly good. So in this case, in 2011, we had about a 26% error rate in identifying that animal as a cheetah. On the right, and as of now, essentially, and the error rate is less than 3%, which is better than what a human can do. And that's pretty awesome. The fact that an algorithm and a machine can now perceive the world in that way opens up lots of new use cases. But of course, as a team, our mission is about bringing machine learning to mobile devices and mobile apps. So when we started researching this product, we went out there and talked to many developers, both internally at Google as well as externally, to try to understand what are you doing with machine learning on devices, and how does it work today? So I'm going to tell you a bit about that. The first team, one of the first we've talked about, is Google Translate. And of course, you hear a lot about Google Translate because it's such a delightful experience and incredibly useful. But what I like the most about Google Translate is the fact that it strings together multiple types of deep learning and machine learning models and technologies to deliver this experience. So it does the on-screen character recognition to extract the text that it's looking at. It then does the actual translation itself, and then ultimately it could do text-to-speech so it can speak the results back to the user. And we think that when you can string these things together, when you can use machine learning in multiple ways within a single experience, where relevant obviously, really cool stuff happens. So that's one example. The other one is this app called Musician. Musician is a music learning app. It essentially allows you to play an instrument in an analog, like an actual analog instrument, and then the device listens as you play and tries to interpret how well you're doing. So it's listening to the specific notes you're playing, it's listening to how well you're playing them, it's time-stamping them, it's doing echo cancellation, and it's also doing noise cancellation. And finally, personalizing the learning experience. All of this is done with an on-device machine learning model. And in fact, when we were talking with this team, they had built their own C++ runtime to actually do the inference on device as efficiently as possible. This predated TensorFlow Lite and other things that we do have now that could have helped with that particular process. The other folks we've talked about, amongst a few others, are Evernote. So Evernote launched a feature called Evernote Collect. And the insight behind Evernote Collect is the fact that we collect so much of our information now in a visual manner. We're taking screenshots of things that we care about. We're taking pictures of receipts. We're taking pictures of whiteboards after a meeting and asking someone to transcribe them. Well, Evernote tries to avoid that. It tries to extract the text and tag the image with that relevant text so you can search for it and find it and make it more useful. So that's super cool. And so the overall theme from what we heard through many conversations was that it's doable. On-device machine learning is doable, but it's really hard. And it's hard for 3 specific reasons. The first is acquiring sufficient data in both the quantity and the quality that you need. And think about it. So let's say you're training an OCR model. You can label the data for your own language, right? You could get an actual training set and say, I'm going to label what this data says myself because I understand that language. But in a global audience, when you have users all over the world, how do you create an OCR model that actually works for all those languages? That's really hard. Or even harder, if you're a music learning app, you need to hire world-class musicians to record the perfect note so you can then actually trade against it. That's expensive. The other aspect is developing models that are optimized for mobile inference. And this has many dimensions. This could be in terms of battery life, in terms of compute, and in terms of size of the model. And what I've learned in machine learning is that these are always constant trade-offs. You can improve on one, but then decrease on the other one. And so it's a really hard challenge to solve. And finally, deploying and ongoing experimentation is essential to machine learning. You can't do one without the other. And so, but however, there aren't very many tools today to help you do that. So we set out MLKit to try to address all of these issues. Of course, it's the beginning of a long road and journey, but we think that we have some exciting stuff for you today. I want to first talk about our machine learning SDK, a machine learning stack. And in this case, the very bottom of it is the Android Neural Networks API on the Android side, and then on iOS is Metal. On the neural network side, we launched it with OMR1, and it's essentially a hardware acceleration interface. Since launch, we've been working with every one of our top SoC vendors to build drivers for the Neural Networks API. And I'm excited to show you some results. With Huawei's P20 series device, we're seeing a 10x improvement in latency on inference with Inception v3. And what's cool, if you don't know Inception v3, it's a really large model. It wasn't built for mobile devices at all. It was built for server-side inference. And the fact that we can run that kind of model at 10x the performance and actually run it quite efficiently on a mobile device that's not connected to a power plant is actually super exciting. This means that we have a lot more headroom to do more with machine learning on a device. Of course, there's another dimension of this where we build models that are inherently built for mobile, that are from the ground up, built to be highly efficient and all of that. And that work continues. So when you pair these two things up together, we think there's going to be a lot of cool stuff happening here. So we're continuing to invest on Android Neural Networks API, and of course relying on Metal on the iOS side. The next aspect here is TensorFlow Lite. TensorFlow Lite, which was announced last year at I/O and then shipped around November, is a lightweight machine learning and set of tools and library. It works on both mobile devices and embedded devices, and it was built from the ground up, as it says, to be lightweight. Now, I'm not going to steal any of the team's thunder. They have a session fully dedicated to TensorFlow Lite tomorrow, and so I highly recommend going to see it if you're at all interested in on-device machine learning, which I assume you would be if you're here. OK, then we get at the application layer. And this is where we looked around and we said, there isn't really an easy way to access machine learning technologies at that layer. You had to either go and interface directly with the runtime and build your own models, or you really had to build your own stack. And so that's where MLKit comes into the picture. MLKit is in beta as of yesterday, so you obviously all can go use it today. And it's essentially Google's machine learning SDK. Our aim is to bring Google's 15 plus years in machine learning, all of the technology we've developed, bring it to mobile developers through this SDK. So let me tell you more about it. Well, first, let me show you the stack again with MLKit at the top. And in fact, this is our on-device machine learning stack. OK, now I hope I get to tell you about it. OK, so the first thing that's really important is that MLKit is both on iOS and Android. And this was really important to us, because when we talk to developers, we don't think about Android machine learning and iOS machine learning. We think about machine learning. We want to deploy similar models to users on both platforms. There's not a fork there. So it was important that we have a consistent SDK for both. And in fact, every one of our features is available on both Android and iOS. We offer two types of rough buckets of features. One is what we call base APIs. These are APIs that are backed by Google models. And so as far as you're concerned as a developer, there is no machine learning involved. The other is a set of features that help you use your own custom-trained models. I'll tell you a lot more about that in a bit. MLKit also offers both on-device and cloud-based APIs. Again, this was important, because on-device APIs give you the real-time and offline abilities, but they have limited accuracy in comparison to cloud. However, on-device APIs are free of charge. But we also wanted to give you a consistent interface for the cloud APIs, because in many cases, you do need that level of precision and that level of scope. And we'll talk about the distinctions between the two in a little bit. And finally, MLKit is deeply integrated into Firebase. And this was really another important point for us. We aim to make machine learning kind of non-exceptional. We don't want it to be special. We want it to just be yet another tool, just like you use analytics or crash analytics or performance monitoring or cloud storage. Just like you use any of those parts of Firebase, we wanted machine learning to be right there and right then. And what this also does is it works well with other features on Firebase. Again, we'll tell you a little bit more detail about that in a few minutes. So that's the high level about MLKit. So what base APIs do we support today? First, text recognition. This is available both on cloud and on device. The second is image labeling. Next is barcode scanning, face detection, and landmark recognition. The 4 APIs on the left are all available on device, meaning you can use them for free and in real time and offline. We also have 2 super cool features coming up soon. One is a high-density face contour feature. This is over 100 points in real time. And the other is a Smart Reply API. And this is what we like to talk about, how at Google we work together really well. So as part of Android P, there is a feature where you can now insert response suggestions within the notification shade directly. So MLKit's Smart Reply API could be something that would be useful in populating those chips. This is the same API used in Wear OS, the same technology, not the same API, the same technology used in Wear OS, Android messages, etc. So that's really cool. But of course, sometimes you simply need to build a custom model. If you're trying to detect that particular type of flower, it's hard to build a generic model, or at least you could build one, but it would be super large to actually detect every flower, every dog, every species of everything. So you have to use base custom models sometimes. And we wanted to help with that as well. The first feature we have here is dynamic model downloads. What this means is you can upload your model to the Firebase console and have it be served to your users dynamically. You don't have to bundle the model into your APK. This has a bunch of benefits. First, it reduces your APK size, Because now you don't have to put that 5 or 10 megabyte model into your APK, meaning that you have to take the hit in the app stores when you're trying to, the user's trying to install your app. But the other really important insight for us was that we decouple the process, the ML release process, from the software kind of traditional app release processes. We've learned that these teams are typically slightly different teams. Your machine learning team is probably a different set of people than the ones that build in your core software experience. So this gives you that flexibility to deploy each at different times. Now, a really cool benefit of this also is you can now do A/B testing on different models with literally a single line of code using Firebase's remote config. This is the coolest part for me. Literally, if you were to do this today, as in maybe 2 days ago before MLKit launched, you'd have to bundle 2 models into your app. You're stuck with those 2 same models for the duration of the app's lifecycle, and you have to then upload all the metrics back and do all of that work. This makes it trivial. And given how important it is to experiment as part of machine learning, this is, we think, a real game changer for our ability to use machine learning models. And finally, we talked about that optimization challenge of building models that are made for mobile. We're excited that we'll have a feature that's coming soon that will allow you to convert and compress full TensorFlow models into lightweight TensorFlow Lite model. And Wei is going to get in stage here in a bit and tell you all about the magic, we call it also technology, behind that compression flow. So that's MLKit, Google's machine learning SDK, available on Android and iOS. I want to take a moment, as always, to thank our partners. We've worked with every one of these partners and many more to launch MLKit. They worked through so many bugs, so many challenges. They've given us so much feedback, and the product wouldn't be where it is today without their help. So I want to thank them a lot. And in particular, I want to highlight a couple of things. So we worked with PixArt, and PixArt uses MLKit to deploy a custom model to use their magic effects experience. And what's cool about PixArt is they're using MLKit both on Android and iOS. We also worked with Intuit. And if you know US tax dates, tax day is around April. And so they were really pressed for time to get the feature out. And so we worked with them to integrate MLKit in record time. So that was super awesome as well. All right. So before I hand it over to Sachin to tell you more about MLKit, I wanted to make kind of a commitment to you. We're going to go out there, and we're going to knock on Google's research team's doors, every single one of them. And we're going to go out there, we're going to ask them to bring their technologies to you to be part of MLKit. We're going to focus on vision, speech, and text models. And we'll also continue to make use of custom models as easy as possible. So that's it. I'm going to invite Sachin to come on up here and tell you more about how MLKit works.
Thanks, Brahim. Hi, everyone. My name is Sachin Kotwani. I'm a product manager on Firebase. I was practicing my presentation at home with my 3-year-old, and every time I finished, she would say, again, again, again. And I'm not sure if she was trying to tell me that I needed to practice more or if she really enjoyed the content. Again, we'll find out. Okay. When we set out to build MLKit, we had 2 main objectives. The first one was to build something that's powerful and useful, and Brahim talked about that. The second one was also to make it fun and easy to use, and I'm going to tell you a little bit more about that. So if you've used Firebase before, you're probably already familiar with products like storage, real-time database, Firestore, remote config, Crashlytics, analytics, A/B testing, and more. And now, there's a new addition to the family. Starting this week with our launch, if you head to the Firebase console, you'll see MLKit on the left nav. Clicking on that will take you to the main screen with our Firebase APIs that Brahim just introduced you to. As you can see, they are mostly vision-focused for now, but we intend to add to it in the future. Let's look at one specific use case. let's say that I'm building an app and it needs to determine what's the content of an image, what the theme is, what things are in it. I would use the image labeling API. As you can see, there are two icons here. This indicates that this API is available to run both on device and in the cloud. On device is free. It's low latency, no network required because everything runs on the phone. It supports roughly 400 plus labels. Now, if you need something more powerful, something that's going to give you more high accuracy results, you would use the cloud-based API. That is free for the first 1,000 API calls per month and paid after that, but it supports over 10,000 labels. Let's look at an example. If you were to feed this image to the on-device API, you'll get labels like fun, infrastructure, neon, person, sky. If you feed it to the cloud one, you'd get Ferris wheel, amusement park, night. You can see that's more accurate, right? Okay. So remember I also told you that it wasn't just fun, it's also easy to use. So you have to hold me to it. Let's say that I want to implement this API on iOS. I would just include these three libraries in my pod file. Similarly, if I'm doing Android, I would put these three libraries in my build.gradle file. Next, if I'm doing iOS on-device image labeling, I would instantiate the label detector, say label detector.detect, and then I get the results back, and I iterate and handle the extracted entities. On Android, the pattern is very similar. You instantiate the detector, detector.detect an image, on success, handle the extracted entities. Now, pay attention to the highlighted boxes in gray over there. This is on device. Now, if I want to do the same thing but call the cloud API instead, not much changes. It's just a few class names. The pattern is very similar. The detector, detector.detect an image, on success, handle extracted entities. Pretty cool. All right, demo time. I was warned not to do a demo, but my wife says that I don't listen, so here's me not listening. And let's see if this works. Okay, so I'm going to show you the image labeling API. This is typically used for things like tagging photos, if you want to know what's in the content of a picture, still picture usually. But I thought it'd be pretty cool to show a live demo with a live stream. So I'm going to take a picture of this toy. It says toy, car, vehicle, tire, bumper. Wow, it's actually picking out all the pieces there. Okay, let me. Oh, it says crowd too, event. I didn't get to test this because when I was practicing, there was no crowd. It was just empty chairs. Okay, so face detection. Switch to this. Okay, so there's a box around my face, as you can see. There's a left eye, right eye. The numbers next to the left and the right eye are how open they are. So you can tell that I'm awake. Happiness is a detector for the smile. So look at how that changes. And this works with multiple people, actually. So just, again, you shouldn't trust me. You should ask me to prove it to you. So I need a few volunteers here. Okay, see, multiple faces detected. Eyes for everyone, smiles for everyone. Huh? Pretty cool? All right. Okay, I have a couple more things. Lose It, as Brahim mentioned, is one of our partners. And they worked on this really cool feature. So I'm going to enter here. Let's say I am logging what I had for breakfast. And normally you could select foods that are already in the application, or you could enter it manually. But let's say that you want to enter a new food. Apparently this is not considered food, so I don't think it's in the application. But I'm going to try it. Okay, so like I said, you could enter it manually, but let's try what happens. Oh, it detected it faster than what I expected. Let me try that one more time. There you go, nutrition label found. And here's all the information, the calories, fats, saturated fats. All right. You want one more? Okay. This is stuff that's not available yet, but I think it's pretty cool. This is our face contours demo. It detects over 100 points, processes them in 60 frames per second, And you can see, my lips, my eyes, the entire face contour. So this will be coming pretty soon. There will be a sign-up link if you're interested. And, we look forward to having it in your hands so you can play with it. All right. Thank you. So that was pretty cool. And hopefully you find those base APIs useful. But there are obviously use cases that you might have that are very specific to your application. What if you want to detect different types of flowers? Or like musician, maybe you want to extract a musical note out of a sound stream. You would want to use your own custom model. And MLKit helps with that as well. So there are three benefits bringing custom models to MLKit. The first one is that the MLKit SDK provides an API layer that interacts with your TensorFlow Lite model. So you can provide inputs, get outputs, just like you would do with the base APIs. Second, you can upload the TensorFlow Lite model to the Firebase console. And that provides two benefits. First, and Brahim alluded to this earlier, is that you can bundle your model with your application if you choose. But if it's big and you want to reduce the install size, you can actually just leave it in the cloud and download it dynamically. So the initial install size is smaller. And the third one, because it lives in the cloud, you can dynamically switch the model. You don't have to submit a new APK or bundle to the App Store or the Play Store. Here's a quick snippet on how you would load that model, how you would refer to it. So let's say I called my model V1. I would put this snippet, and it would retrieve it from the cloud. Now, let's take a step back. When I started, remember I mentioned that there are a lot of other Firebase products that are very useful. And one of my favorite ones, is remote config. And what it does is it allows you to dynamically switch values inside your app. It's typically used for things like, switching the color, the background. You can also use it to switch call to action strings. It's really useful for that sort of thing, but it turns out that it's also very useful for MLKit. So here's what I did. I went to the Firebase console, and I created a parameter called myModel. Then I created 3 different target populations. One for people who speak English, another one for people who speak Spanish, and then a default value. So what I'm trying to do here is I'm targeting a different model to those different populations. And once you do that, instead of hard-coding a model name, like is here, you just change that static string for a call to remote config, and then every device, depending on what population they belong to, they'll get their respective model. And this is just a very simple example. You can think of using A/B testing and analytics, so you can test out different models, and you can pick the one that performs best and choose that. So experimentation, as Brahim said earlier, is important in machine learning. All right. Before I wrap up and hand it over to Wei, I want to talk about this compression and conversion of TF models. So let's say you have a TensorFlow model, but what you need is a TensorFlow Lite model to run on device. We have a feature for that, and it's coming soon, as I said. You would upload your TensorFlow model along with training data, and once it's done processing, you'll get a bunch of TensorFlow Lite models to choose from. As you can see, these would be compressed, and they have trade-offs. So they have different accuracy, different inference latency, and different sizes. So depending on what you're most sensitive to, you can pick the one that suits your needs. This flow is currently only for image classification models, but we look forward to adding more in the future. Okay, so you'd pick the model that works best for you, you publish it, and then it's just available like any other custom model that you would upload on your own. I know I made this seem super easy with like a beautiful UI and just 3 steps, but this is actually really hard to do. It's an active area of research. It's almost like magic. And to tell you more about that magic, I'd like to invite our resident wizard, Wei. Please come up on stage.
Thank you, Sachin. Hi, my name is Wei. My team, actually right here, my team has mixed machine learning experts and mobile developers. It's been a lot of fun to be part of it and build something that we all believe can be useful. For example, model compression. Now, I'd like to go deeper into the technology behind the magic. But first of all, let me explain why we wanted to support model compression. Running machine learning on the cloud versus on mobile. One big difference is that the mobile environment has very limited computational resource. This makes the model size and the inference speed extremely critical. For today's hardware limit, most mobile applications require very small models, ideally less than a couple megabytes. So on the other hand, if we look at the model architectures proposed by researchers for, say, image classification, to obtain higher accuracy, the machine learning models can go much deeper and larger, sometimes hundreds of megabytes for certain applications. After talking to a lot of mobile developers, we realized that how to make machine learning models small and efficient enough to fit on mobile phones is one of the big pain points. With MLKit, we'd like to address this issue by providing model compression, tooling, and support. So a model compression service or tool takes a large pre-trained model as input and automatically generate models that are smaller in size, more memory efficient, more power efficient, faster in inference speed, with minimal loss in accuracy. As Sachin just mentioned, this is still an active machine learning research area. And our compression service is based on Learn to Compress technology developed by Google Research. And it combines various state-of-the-art model compression techniques. For example, one method called pruning reduces the model size by removing the less contributing weights and operations in the model. We found that for certain on-device conversational models, pruning can further reduce the model size by up to 2x without too much drop in accuracy. So another method is trying to reduce number of bits used for model weights and activations by quantization. For example, using 8-bit fixed point for model weights and activations instead of floats can make the model inference run much faster, use lower power, and reduce the model size by 4x. Specifically, with TensorFlow Lite, switching from MobileNet to Quantized MobileNet can speed up the inference by 2x or more on Pixel phones. So the third method trains a compact model called a student model with distilled knowledge from a large model, a teacher model. So the student does not only learn from the ground truth labels, but also the teacher. Typically, the student models are very small in size with much less weights in the model and use more efficient operations for the benefit of inference speed. For example, for image classification, the student models can be chosen from MobileNet, NASNet, SqueezeNet, or any other state-of-the-art model architectures compact enough for mobile applications. We can further extend this distillation idea to simultaneously train the teacher model and multiple student models with different sizes in a single shot. One thing to mention is that very often, for all these techniques, we need a fine-tuning step for the best accuracy. So in this case, we do not only need the original model for the compression process, but also your training data. So for MLKit, we'll provide a cloud service for model compression. For now, we only support image classification use cases, but we'll soon expand to more. So the reason that we support model compression as a cloud service, as I just mentioned, model compression is still an active research area with new techniques and new model architectures specifically for mobile applications invented very fast. For example, from MobileNet v1 to MobileNet v2, it took less than 1 year to invent. So our compression service will automatically incorporate the latest advances in technology for you. Another reason, the compression process typically takes quite some computational resource. It can run multiple hours on GPUs. So we will run our cloud service on Google Cloud to use the computation power there. So what we need from the developers include a pre-trained TensorFlow model in saved model or checkpoint format, and your training data in TensorFlow example format for the fine-tuning step I just mentioned. What we generate will be a set of models with different size and accuracy trade-offs for you to choose from. Since MLKit is running on top of TensorFlow Lite, all our generated models will already be in TensorFlow Lite format for you to download or serve through our model hosting service. So with MLKit model compression service, we're aiming to compress a model up to 100 times smaller depending on your use case and the original model. To give you a real developer use case as example, FishBrain is a local fishing app. They already have their model to identify fish species, and the model is currently running on the cloud. With our model compression service, the original model provided by the developer with 80 megabytes and 92% top 3 accuracy can be compressed to much smaller models with different size and accuracy shown here. As you can see, in this particular case, the accuracies of the generated models were even higher than the original model, which is not always the case, but it's possible, and it's great. To summarize, with MLKit, we'd like to make machine learning accessible to all mobile developers. To achieve that, we'd like to help with every single step in the machine learning workflow, not only how to use the model, but also how to build and optimize your model. Now, I'd like to conclude the talk with a summary of what we'll provide. We are launching in beta the base APIs for both iOS and Android, including text recognition, image labeling, barcode scanning, face detection, and landmark recognition. We are also supporting custom APIs with TensorFlow Lite model serving. Please check out these features at Firebase website. Meanwhile, we'll have a set of new features coming out soon, including high-density face contour API, smart reply API, and model compression and conversion service. We'll soon start to whitelist developers to try them out. If you are interested, please use this link here to sign up. We're super excited about MLKit and how it potentially can help developers build cool machine learning features. Look forward to your feedback, and we're committed to making it great. Thanks for coming, and if you have questions, we'll be available right after this talk at the Firebase Sandbox Q&A area. And we are also having some relevant sessions and talks for you to check out. Finally, please leave your feedback about this session for us to improve for the future. Thank you.